On the smart board too, by the way, people. Good morning, everybody. All right, 6-3, guys. We're talking about rotation. We're going to take something. We're going to put your little hands up in the air. We're going to take something, and we're going to rotate it. Okay? Now, everybody either take your notes, or I don't care what, either your notes or the trace paper, hold perfectly straight up in the air like this. Okay? Okay, do this one. Okay. Take your note, hold your notes, not your pencil. Okay. What I want you guys to do, we got to talk about this first. Rotate your paper 90 degrees to the right. That's a 1/4 turn to the right. Okay? That's clockwise 90 degrees. Go back to the original. What would you do if you were asked to rotate it 180 degrees?
Flip it upside down.
Or turn it how many times?
Twice.
Twice. 90 degrees twice. So, watch this.
Bang.
90, 180. Flip it upside down. Harrison's right about that. Turn back to the original. Okay? What would you? How many times would you turn it if you were asked to turn it 270 degrees clockwise?
3 times.
Okay? Why is it always 90? Like, why does it go by 90s every time? Anybody know that?
That makes
Dude, what if we turned it 4 times 90 degrees each time?
360.
You'd go all the way around. You'd be back where you started, which is how many degrees?
You just keep it like that.
You would just keep it like. But how many degrees is a full turn, people?
360.
Yeah. 90, 180, 270, 360. You'd be right back where you started. Now, what's the opposite of turning something clockwise?
Counterclockwise.
Counterclockwise. Watch this. Everybody put your paper in front of you. Turn it 90 degrees counterclockwise. What's the same thing as turning 90 degrees counterclockwise?
Turning it 270 degrees clockwise.
Turning it 270 clockwise. Think about that. If you turn it 90 counterclockwise, that's the same thing as turning it 270 clockwise. You're going to have to know things like that. Okay? All right. That kind of the turning, does that kind of make sense?
But 180 stays.
So here's the deal. Turn it 180 clockwise. What's the same thing as turning it 180 clockwise?
180 times.
Yeah, 180 counterclockwise, you do the same thing. Think about it. Okay? So, that's what we're doing. And these are called rotations. A rotation is a transformation in which a figure is rotated or turned about a fixed point. We're going to do ours through about the origin. Though you can turn it around a different point if you wanted to. All right, the size and shape of the figure stays the same, and the center of rotation, they have to give you that in the problem. What's the center of rotation?
The origin.
Okay, for our purposes, the fixed point is going to be the origin.
I was right.
You're always right, Harrison.
No, it's not.
Come on. All right, rotation's about the origin. Here we go. A rotation is a transformation around a fixed point. Each point of the original figure and its image are the same distance from that center of rotation. Rotations shown are clockwise rotations about the origin. All right, does everybody see 3 rotations here, 3 shapes?
Yeah.
All right, the first one is a 90-degree rotation. Jot that down. Look at the second one. Can anybody figure out what kind of rotation that one is?
180.
That one's 180 degrees. Notice, it went 90 and went 90 twice. What do you think the third one is?
270 degrees.
Now, we will let you guys use this little cheat sheet, okay, on the quiz or the test, because here's what's going on. The x's and y's, when you rotate it 90 degrees, they switch, and the x turns negative. Well, it then becomes the y. Very good. Okay? The x's and the y's switch. We do an example, you're going to be like, holy cow, this is the easiest thing ever. The x's and the y's switch, and we take the opposite sign of the x value, which is now the y value. If it switches 180 degrees, Harrison, what was that word you used right off the bat?
The origin.
Well, it flipped her all the way around on a 180-degree rotation,
Oh, it's upside down.
right? Upside down. look what happens to the x's and the y's.
They turn negative.
They turn negative. Or what if they were negative, Bill?
Then they turn positive.
They turn positive. Okay? 270-degree rotation. The x's and the y's flip, but the y value, we take the opposite sign of it, and it is now the x value. Again, you will not have to memorize this. I remember having to memorize this in high school. We're going to let you guys use this cheat sheet. It'll help you. And you guys are totally going to get it when we do an example. Mr. Trace.
Are those the points on the graph?
Yes.
Okay.
Good question. All right, let's do this. All right. You can do two directions of rotations. One is clockwise. Which way does clockwise turn?
Right.
Right.
From the top, okay, to the right. And then what's the opposite of clockwise?
Counterclockwise.
Counterclockwise. And that's going to go to the left. Okay, we already discussed that. You have three main types of rotations. 90 degrees, a quarter turn. So we turn the paper one time, guys, 90 degrees. We have a 180-degree rotation. That's actually going to be halfway around. Okay? And then we have a 270-degree rotation. And that's going to be 3/4 of the way around. All right, so far so good? Sweet, let's try one of these. All right, triangle DEF has vertices at B, E, and F. Graph the figure and its image after a clockwise rotation of 90 degrees about the origin. Important information, guys. 90 degrees about the origin. They have to tell you in the problem how it's going to rotate. Then you got to give the coordinates, guys, of the rotation. So first thing, everybody graph the original triangle, DEF. Take your time. Be careful. Let's get DEF graphed. -4, 4. There's D. E is at -1, 2. And F is at -3, 1. What quadrant, guys, is that in? 1 or 2?
2.
Remember, quadrant 1's way over here on the right, and it goes counterclockwise. This is quadrant 2. We're going to rotate this 90 degrees. Now, I don't have the ability to do what you guys are about to do because I can't put things on the smartboard. It's too sensitive. What you're going to do is you're going to take your trace paper now. Okay? You're going to take your trace paper, set it carefully. And remember, use your trace paper wisely. It's the only one you get. So kind of, use it like a corner of it or something. All right. Watch me do it first, and then you guys do it. Listen. Look. Okay. Put your trace paper on your graph. You have to trace your x and y axis first. That's going to help you keep things straight as you rotate things. So, everybody, trace your x and y axis, and then trace your triangle on the trace paper. You can do that. Careful. Keep everything nice and straight. Great job. Guess what you're going to do next?
Flip it.
Say it more intelligently than that, Harrison.
Turn the paper.
Which way?
Rotate it clockwise 180 degrees.
No.
90.
90 degrees. So wait. Let me do it. Here's what you're going to do. You got everything traced on there. Turn it 90 degrees to the right, clockwise, and then here's what you have to do. You have to take your new vertices of your triangle and put them, try to puncture right through your trace paper onto your graph and get the new vertices. See if you can do that.
So trace the triangle.
Yeah, trace the triangle, the original one, and then turn it 90 degrees clockwise. Trace. See if you can do that.
Then trace the other triangle.
And then trace the other, and see if you can come up with the vertices of the new one. Because it should line up right on a nice point, guys. It should line up nice and neat. Yeah, trace. Oh, wait, straight. Hey guys, everybody, maybe stand up and look this way. Let me show you a trick. Stand up, watch how I do the traces. Look at this. Take your pencil and put it on the origin. And then turn your paper. Now you don't have to do that. Now. Good job. They're over here or there. It's one of the 2 points. You know? That looks pretty good. See if you can come up with the points D prime, E prime, and F prime. All right. Again, I cannot trace up here on the smartboard. Look at my pen.
Oh, I did it wrong. I did it the negative. I did it counterclockwise.
No, you did it clockwise. Come on. You want to move this way?
I tried it out. Oh yeah.
You did it right.
Yeah.
Oh no, you didn't do it counter.
This.
Wait. Here was the original, right?
Wait.
There is a
So
problem.
you don't want to do a new one. You just turn it.
Oh okay.
And then that needs to go onto the bottom part.
This one here.
I'll trace here.
This
I
one
got
here.
it. Okay, here's the deal. If you rotated it correctly, your new coordinates should be something like this.
Maybe keep going and make it all more quadrants.
Did anybody happen to get D prime?
Yes.
What point's D prime?
4, 4.
I got 4, 4. Anybody else get that? Let me do it in a different color. D prime is at 4, 4. And then I'm going to show you guys probably a way you might like it doing it more than this way. Did anybody get E prime?
Yes.
There's D prime. What was E prime?
1, 2.
Switch those. I think it should be 2, 1.
Oh yeah.
So 2, 1. Did yours line up about right there, Trace? And what about F prime?
1, 3.
I got 1, 3. Look, guys, look at it. It should look like a 90-degree rotation. Look at that. Looks pretty good to me.
Yes.
Okay? Now, watch another way how you can do this. Turn back to the front page. From our rotations around the origin little cheat sheet, how does a 90-degree rotation work? What do X and Y become? Look at the symbols down at the bottom. What do X and Y become, people? Nah.
They flip.
Y comma negative X. Does everybody see where I got that from? Look at the front page. The symbols. Show your neighbor if they're not sure. XY becomes Y negative X. So watch this. D, which was negative 4, 4, becomes D prime 4, 4. Look how I did that. It becomes Y negative X, so I took the Y value, put it first, and I switched the sign on the X value and put it over there. E prime, or excuse me, E, negative 1, 2, becomes E prime. So, XY 2, comma 1. Boom. Perfect. And then F, negative 3, 1, becomes 1, 3. So, 2 ways you can do it. You can either trace it on your trace paper and turn it, rotate it, or you can use the front page and see how the new coordinates become from the old ones. Which way do you guys like doing it?
I don't like using the trick.
Guys,
Yeah, I like doing
this is genius.
I like just tricking it out. So do we have to use a trick?
You don't have to, no. But you gotta write something down like this, Al. Like, use your cheat sheet.
Yeah.
Okay? Let's try another one, guys. You're doing great. Triangle JKL has vertices at 3, 1, 3, -3, and 0, 3. Graph that and its image after a clockwise rotation of 180 degrees. Here we go. 180 degree clockwise rotation around the origin. Find the coordinates of J prime, K prime, and L prime. All right, 3, 1. Let's graph the original. J. 3, -3. Okay, and then 0, 3. It's L. Okay, so it looks kind of like an obtuse triangle to me. In quadrants 1 and 4. Part in 1, part in 4. 0, 3. Use 0 to -3. Okay? Now, try to trace it and clockwise rotate it twice. 1, 2, and see what happens. Okay? Or I'm going to use my cheat sheet at the beginning. 180 degree rotation says that xy becomes -x, -y. Basically, you just switch the signs. Everybody see where I got that information from? On the first page? Okay, so J at 3, 1 becomes J prime, which would be -3, -1. K,
Pretty neat.
3, -3 becomes K prime, -3, 3. Should have K prime, guys, at -3, 3. And then L, which is at 0, 3, becomes L prime at 0, -3. Graph those points. -3, -1. There's J prime. -3, +3. Interesting. There's K prime. And 0, -3 is down here. That would be L prime. What do you guys think? Does that look like a 180 degree rotation to you? Pretty cool. It turned once and it turned twice. Okay? You can either trace it, you got some trace paper, or you can use how do the X's and Y's change based on the original,
I like that one.
based on our rotation from the cheat sheet. Okay? A lot of information today.
I'm not good at that. So
You guys can do this. All right, let's jump to the next one. Let's see if we can do this a quadrilateral.
it looks like a lot.
All right, quadrilateral, MNPQ. Graph the figure and its image after a, counterclockwise rotation of 270 degrees about the origin. What would be the same thing as counterclockwise 270?
Clockwise 190.
Guys, that would be the same thing as clockwise 90 degrees. Does everybody agree with that? Think about it. Counterclockwise 270, 1, 2, 3 would be the same thing as 1 going clockwise.
So can we just do that?
Yes, that's how you should do it. Because we know how 90 degrees clockwise rotations from our cheat sheet, xy, become y -x. There's how the points move. Okay, let's graph the original. 2, 5.
This is where
There's M. 6, 4. N. P is at 6, 1. Q is at 2, 1. So it looks like a trapezoid, guys. Like a trapezoid. And what we're going to do is we're going to turn this thing 1, 2, 3. It's going to end up down in quadrant 4. Okay? Or the same, remember, if you're tracing it, guys, you could always just turn it one time 90 degrees clockwise, because that's the same thing as 270 counterclockwise. All right, let's see what the points are going to become. M is at 2, 5. So M prime with a 90 degree clockwise turn becomes, can everybody figure that out? 5, negative 2. Switch your y's and your x's and take the opposite sign of just the x's. N is at 6, 4. So what would N prime be? Shushko? 4, negative 6. P is at 6, 1. What would P prime be?
1 comma negative 6.
Beams, what do you think?
1 negative 6.
Is it 1, negative 6?
Next.
And then, what's the last one? Q is at 2, 1. Henning, what would Q prime be? 1 comma negative 2. And guys, you can fill those in those blanks. Let's see how this looks. 5, negative 2. There's M prime. 4. Is that right? 4, negative 6. 6. There's N prime. P prime is at 1, negative 6. This is going to work out. And at 1, negative 2 is Q prime. What do you think, guys? Does that look like a 90 degree turn clockwise? Looks good to me. Okay, so using your trace paper or using the rules from the first page. All right, last problem. You guys are doing great. Let's do a 90 degree counterclockwise rotation. What's the same thing clockwise as a 90 counterclockwise?
270.
This would be 270 degrees clockwise. Okay, that's the same thing as 90 counterclockwise. Let's see. Let's graph 3, negative 1, 5, negative 4, and 1, negative 5. So we're down in quadrant 4 again. Can anybody figure out where it's going to end up? What quadrant is that thing going to end up with a 270 degrees clockwise rotation?
Quadrant 1.
Quadrant 1. It's going to end up over here, guys. 1, 2, 3, clockwise. 390 degree clockwise rotations. It's going to end up there. Let's see, 270 from my cheat sheet. X, Y become negative Y comma X. I got that information, guys, from the front sheet. Use it. 3, negative 1. Anybody get X prime yet? Smale. I did not get that.
1 comma 3.
Switch the sign on your Y.
Oh.
Because it's negative Y, and Y is negative, so it becomes positive, and then so
I
it's,
thought you kept the negative.
well, it's when it says negative Y, it means the opposite of whatever Y was. So negative sign kind of means the opposite. All right, point Y was at 5, negative 4. Catherine, what would Y prime be then?
4 negative.
Don't switch the X value. So X value is going to stay 5. 4, 5. And then z is at 1, -5, becomes z prime. Anybody get z prime yet? Mir, what's z prime?
5, 1.
I think it's 5, 1. Let's graph those points. 1, 3. Why am I using 1, 3. There's x prime. Y prime is at 4, 5. There's y prime. And z prime's at 5, 1. Look at that, guys. That looks like a pretty cool rotation. 270 270 clockwise or 90 counterclockwise about the origin. Okay? Guys, you're going to have to use your notes to get through your homework tonight.